Hi, I'm Ms. Boone. Today we're going to solve trigonometric equations. Example 1. Find the solutions to sine x equals 1 over root 2 where x is between 0 and 4 pi. Well, we know that sine x is equal to 1 over root 2 when we have this triangle over here, pi on 4. Opposite of a hypotenuse is 1 over root 2, so pi on 4. And we call this first answer the first quadrant angle, pi on 4. Now we can find other solutions between 0 and 4 pi because we know that sine x is equal to 1 over root 2, not in just that quadrant there, but also in the quadrant that it's also positive, which is over here, or station 2 Caulfield. So when we get over here, by symmetry, we'll also have 1 over root 2. So we need to find what angle that is. And we can recall that the graph looks like this, and we can see that 1 over root 2 for sine x, this is sine x, is this point here, and between 0 and 4 pi, we have another 2 points as well. So it's 4 points that we have to figure out. Now, first of all, let's figure out the first 2 points. And recall that this graph sine is the y value. So as we go through the first quadrant, it is positive. The second quadrant, it's still positive. And the third quadrant, it is negative. And the fourth quadrant, it is negative. So the first 2 answers we saw are from the first and the second quadrant. So the shortcut, without having to visualize all of this, is to say, okay, it's positive. Which quadrants are positive? It's A, S, T, C, so first and second quadrant. So then we're going to find the solution to the first and second quadrant. So the first quadrant, well, that's easy, that's pi on 4. The second quadrant would be pi minus pi on 4, which is 1 minus a quarter. 4 minus 1 is 3 pi on 4. So now we have our first 2. Then we ask ourselves, how do we go from here to the next exact same point? That is, how far is that away? That is exactly 1 period away. So if I go from pi on 4, how do I get to that point there? I add a period. And if I go from 3 pi on 4, how do I get to that point over there? I also add a period. So let's add a period to these 2 solutions. So pi on 4 plus a period, well, the period is 2 pi in this case, is, well, a quarter plus 2. 2 is like 8 over 4. So 8 plus 1 is 9 over 4 pi's. And for this one, 3 quarters plus 2. 2 is like 8 over 4. So 8 plus 3 is 11 pi on 4. So now we have our 4 solutions. Pi on 4, 3 pi on 4, 9 pi on 4, which is over 2. You see, it makes sense. And 11 pi on 4, which is just under 3 pi's. 11 quarters is just under 12 quarters. So it's just under 3 pi's. So let's recap because that's a lot of steps. Step number 1, figure out what the first quadrant angle is by using the triangles. Now that you know that that's the first quadrant angle, figure out, well, if it's positive or negative, which quadrant we're talking about. So in this case, it was positive. So we're talking about first and second quadrant for sine. Figure out the angles for those 2 quadrants. That's the first 2 solutions. And then use the period to find other solutions. Let's do another example. Example 2. Find the solution to sine x when it's equal to negative half, where x is between negative pi and 4 pi. Now the first quadrant angle is, well, a half. So don't worry about the negative. A half, sine is a half when it is opposite of a hypotenuse, pi on 6. So our first quadrant angle is pi on 6. Step number 2, we're looking at negative. So we're looking at AS, all station 2 Caulfield, ASTC. So sine is negative here and here, or quadrant 3 and quadrant 4. So we need quadrant 3 and quadrant 4 angles. And just look at the graph. First, second, third quadrant and fourth quadrant. Sine is negative a half in the third and fourth quadrant. So we're looking at these 2 solutions first. Just check the period is still 2 pi. Okay, so we're looking at that one. So that is pi plus our first quadrant angle. So pi plus pi on 6, which is 1 plus 1 and 6 is 1 and a 6, which is 7 pi on 6. and that is 2 pi minus pi on 6, which is 12 minus 1 is 11 pi on 6. Now we have these two solutions. We need to go that way, so we're going plus pi to these two. So it's plus period, not plus pi. So the pi is when we're going around in a circle, plus period is when we're looking for other solutions. So plus the period, 7 over 6 plus 2 pi is 7 over 6 plus 12 over 6. So 12 plus 7 is 19 over 6 pi. 11 pi over 6 plus 2, or 11 plus 12 is 23 pi on 6. So we've got 1, 2, 3, 4. So we can clearly see that there's another two solutions. How do we get from here to here? How do we get from this point here to this point over here? We would subtract a period. But be very careful that you're subtracting a period from the middle values, because if you subtract a period from the final values, you would end up over here where we started. So we need to subtract from these values, not these values. So 7 pi over 6 minus 2 pi. So 7 over 6 minus 12 over 6. 7 minus 12 is minus 5 pi on 6. And 11 pi on 6 minus 2 pi is 11 minus 12 is minus pi on 6. So we can see that one is there. See, that second one becomes that minus pi on 6, and that one there is that one over there. So you add a period, subtract a period, depending on whether you go to the right or the left. Now let's write our solutions. We write from leftmost to the rightmost solution. So we go that one there, minus 5 pi on 6, minus pi on 6, and then 7 over 6 pi, 11 over 6 pi, then the 19 and the 23. It looks a little bit jumbled up, but if you can visualize it, it will really help. Let's do another example. Example 3. Find a solution to cos theta when it's equal to a half between 0 and 3 pi. Again, what do we start with? The first quadrant angle. So let's have a look at a half. That happens when adjacent over hypotenuse. So the angle adjacent means this is the angle, pi on 3. After that, we sketch the graph between 0 and pi on 3, and actually, you don't actually need to sketch the graph. I'm just using the graph for your understanding. The first step is quadrant angle. Second step is look at, is it positive or negative? It's positive, so we look for when cos is positive at all station 2 Caulfield. So it's positive in the the first and the fourth quadrant. I'm just using the graph to show you so you can understand. You don't need to draw the graph unless the question states it. So we can see that's 1 and 4. See, 1, 2, 3, 4. See, the answers are in 1 and 4. So first and fourth quadrant. The first quadrant, that's pi on 3, and the fourth quadrant, that is 2 pi minus pi on 3, which is 6 minus 1 is 5 pi on 3. So we have our first two answers, that one and that one. We need to find the other answers. So we do that by adding a period. Now notice that when I add a period to that value, I get 7 pi on 3. So a third plus 2 pi is 7 pi on 3. But when I add a period to 5 pi on 3, we see that 5 pi on 3 plus 6 over 3, that's 11 pi on 3. That is 11 pi on 3, that is more than 3 pi's, because 3 pi is 9 pi on 3. 11 pi on 3 is more than the domain. And we can observe that 11 pi on 3 is outside the graph. It's going to be over here. So we don't want that answer. We only want 3 answers. So pi on 3, 5 pi on 3, 7 pi on 3. Now why am I showing you the graph? So you can visually see what happens. But how do you check? What is your process of answering this question? First quadrant angle, then figure out positive, which quadrants they are. Do your first two answers, and then add a period, because we're going between 0 to 3 pi. We're not going negative, so we're adding periods to go to the right. And then you keep finding answers until you find an answer that is outside your period. 7 pi on 3 is less than pi on 3. It's inside the period. But 11 pi on 3 is way more than 9 pi on 3 or 3 pi on 3 pi's. That's outside our domain. So that one doesn't count. So we stop. Example 4. Find the solutions to cos x where it's equal to negative 0.58, where theta is between 0 and 360. So this time we have a numerical value. It is negative, so we know in step 2 which quadrants we're picking, but in step 1, how do we find that? We can use a CAD calculator. Okay, we want to find the angle, so let's bring up keyboard to find trigonometry. So not math 1, trigonometry is here. And to find the angle, we inverse cos to find the angle. Make sure that your calculator is in degrees over here by clicking DEG. Now 0.58 would give us 54.5 da-di-da, so 54.5. Okay, so after you obtain the first quadrant angle, what do? You look at the quadrant. So we can see that cos is negative in the all station 2 core field, the second and the third quadrant, and we can also visualize it with the graph. First, second, third, fourth, so second and third, those are the values of negative 0.58 that we want. So the second and third quadrant, we obtain it by doing 180 minus 54.5, and the third quadrant, we do it by 180 plus 54.5. And then after that, do we need to add or subtract a period to go to the next slot of answers? No, because their domain is between 0 and 360. So we have our two answers, 125.5 and 234.5 degrees. Thank you for watching. I'll see you next time. Bye.